Right, in this video, we're going to talk about chapter 1, dealing with equations and inequalities. And starting with the first section, we're going to deal with graphs and graphing utilities. All right, and pretty much throughout this course, we'll talk about how to use graphing calculator to do problems. What we'll look at in this section is to plot points in the rectangular coordinate system. Also, we'll be graphing equations in the rectangular coordinate system and also use a graph to determine intercepts. Okay, so first of all, we'll introduce you to points in ordered pairs and also the rectangular coordinate system. Okay, so here the rectangular coordinate system, or sometimes called the Cartesian coordinate system, it consists of two number lines that intersect at right angles at their 0 points. So here's an example of a rectangular coordinate system. We have two vertical lines, well, actually two number lines. One goes horizontally this way, and the other one goes vertically like this. They intersect at a 0 point, which is this point right here. The point of intersection is their 0 points, which is called the origin. So in this case here, this is the origin right here where that red dot is at the center. And the ordered pair for that is always going to be 0, 0. Positive numbers are shown to the right and above the origin. So here to the right is your positive values. Above the origin is the positive values as well. Negative numbers are shown to the left and below the origin. So here your negative values are to the left and below the origin. Now, the axes divide the plane into 4 quadrants. So here we have the first quadrant in the upper right corner. The upper left is the second quadrant. The lower left is the third quadrant, and the lower right is the fourth quadrant. Now, the points located on the axis are not going to be in any of the quadrants here. Okay. So in this case here, in the first quadrant, your x values and your x coordinates and your y coordinates are positive. Okay. Now in the second quadrant, the x coordinate is negative and the y coordinate is positive. And in the third quadrant, the x and the y coordinates are negative. And in the fourth quadrant, the x coordinate is positive while the y coordinate is negative. Okay. So here we're going to be dealing with ordered pairs. Usually it's going to be in the form of x, comma, y. This is considered to be an ordered pair. Now, how do we plot points on a coordinate plane? Each point corresponds to an ordered pair of real numbers, x, comma, y. The first number is called the x coordinate, and the second number is called the y coordinate. To plot points, we go left or right along the x-axis and then go up or down parallel to the y-axis. Okay. And we always look at the sign. If it's positive, you're going to go to the right for your x, or negative to the left if it's negative. And then from there, you'll go up if it's positive or down if it's negative, parallel to the y-axis. Like in this example here, let's say I want to plot the points A, which has the ordered pair -2, 4, B with the ordered pair 4, -2, 3, C with the ordered pair -3, 0, and D, 0, 3. In this case, let's start with point A, which has the coordinates -2, 4. We always start at the origin. Excuse me. And from the origin, our x coordinate is -2, so that means I need to go to the left 2 places. And then my y coordinate is 4, so I go up 1, 2, 3, 4. And this will be point A, with the ordered pair -2, 4. And now for point B, with the coordinates for -2, we start at the origin. So that means we go to the right, 1, 2, 3, 4. And then from there, my y coordinate is -2, we go down 1, 2, and draw that point. And here I'll label that as B. Now point C has the ordered pair -3, 0. So we start at the origin, we go to the left 3. Now my y coordinate is 0. That means I don't go up or down. So that means at this point, C is going to be on the x-axis. And then finally D, which has the ordered pair of 0, 3. We start at the origin. We don't go left or right because our x coordinate is 0. But our y coordinate is 3, so that means we need to go up 3 places and draw the point. This point would be on the y-axis, so point D is on the y-axis. Okay. So that's pretty much how we plot ordered pairs on a coordinate plane. Okay, now let's talk about how to graph equations. Says here, a relationship between two quantities can be expressed as an equation in two variables. A solution of an equation in two variables, x and y, is an ordered pair of real numbers with the following property. And that's this: when the x coordinate is substituted for x and the y coordinate is substituted for y in the equation, we have a true statement. We can also say that the ordered pair satisfies the equation. So here the graph of an equation in two variables is the set of all points whose coordinates satisfy the equation. And here we're going to use the point plotting method to graph this equation, to graph any linear equation. And that's going to be this. Here we're going to find several ordered pairs that are solutions of the equation. And then second, plot these ordered pairs as points. And then third, connect the points with a smooth curve or a line. Okay. So let's take a look at this equation. Well, we got this. We want to graph y is equal to 7 minus x squared, selecting integers starting with -3 and ending with 3. So what we're going to do is create a table of values here. So I'm going to create an XY table. And this is going to be y is equal to 7 minus x squared on the left side. And we're starting with -3. So we go from -3, -2, -1, 0, 1, 2, and 3. Those will be my x values. So for each x value, I will substitute it for x in this equation to find what my y values are going to be. Okay. And you can also do this on the calculator as well if you like. So in this case here, for x equal -3, we're going to have 7 and then minus, and then we're going to substitute our x or -3. I'm putting that in parentheses, by the way, and then square. The x squared key is right on the left-hand side on the far left. Okay. So when I do that, I'm going to have -2. And I know that because if I square -3, that's like -3 times -3, which is 9. And then 7 minus 9 will give me negative 2. So I have one ordered pair, negative 3, negative 2. Okay. Maybe if I do it like this, just write it out like 7 minus negative 3, and then that's squared. That gives me negative 2. So I have one ordered pair, negative 3, negative 2. And then for x equal negative 2, substitute the x with negative 2. So I have 7 minus negative 2, and that's squared. If I square negative 2, that's going to be positive 4. 7 minus 4 is 3. And then for x equal negative 1, this will be 7 minus negative 1 in parentheses, and that's squared. Square the negative 1, that will be 1. 7 minus 1 will be 6. And then for x equals 0, just substitute 0 in for x. 0 squared is 0. 7 minus 0 is 7. And then for x equal 1, I'll do 7 minus 1 squared. Well, 1 squared is going to be 1. 7 minus 1 will be 6. And then for x equals 2, this will be 7 minus 2 squared. Well, 2 squared will be 4. 7 minus 4 will be 3. And then finally for x equal 3, so it'll be 7 minus 3, and that's squared. 3 squared is 9. 7 minus 9 would be negative 2. Okay. So these are going to be all my ordered pairs for this equation that I will use to graph. Now I'll write this out on the side. Negative 3, negative 2, 2, negative 3. 2, 3. Negative, and that should be negative 2, 3. Negative 2, 3. Then negative 1, 6. 0, 7. 1, 6. 2, 3. And 3, negative 2. And I will be plotting those on the coordinate plane. So in this case here, negative 3, negative 2 will be to the left 3 and down 2. And then negative 2, 3 would be to the left 2 and up 3. And then negative 1, 6 would be to the left 1 and up 6. 0, 7 would be at 0, but you're going to be up 7. So that point will be on the y-axis. And then 1, 6 will be to the right 1 and up 6. And then 2, 3 will be to the right 2 and up 3. And finally, 3, negative 2 will be to the right 3 and down 2. So these are my points for this graph. And in this case, it's going to be a curve. And it is a special type of curve that we'll look at later on, which is a parabola. We'll be talking about that in chapter 3. All right, here's another example of this. Selecting integers for x starting with negative 3 and ending with 3, we want to graph y equal 4 minus x. Okay, y equal 4 minus x. So here we're going to do an xy table of values. My equation is y is equal to 4 minus x. And we're starting from negative 3 to 3. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. So again, for each x, I'll substitute in this equation to find out what y is. So if x is -3, I'm going to have 4 minus a -3. 4 minus a -3 is the same as 4 plus 3, which is 7. So one ordered pair would be -3 and 7. And then for x equals 2, we'll have 4 minus a -2, which is the same as 4 plus 2. That will be 6. So -2 and 6. And then for x equal -1, x equal -1, this will be 4 minus -1, or 4 plus 1, which is 5. So I have another ordered pair for that, -1, 5. For x equals 0, this will be 4 minus 0. That'll be 4. So I have 0, comma 4 as another ordered pair. And then for x equal 1, this will be 4 minus 1, which is 3. So 1, 3 is another ordered pair. And then for x equals 2, this will be 4 minus 2, which is 2. So I have another ordered pair, 2, 2. And then finally for x equal 3, this will be 4 minus 3, which is 1. So my last ordered pair is going to be the ordered pair 3, 1. And now I'm ready to plot those points on the coordinate plane. Starting with -3, -7. Here we go to the left 3 and down 7. And then -2, 6 will be to the left 2 and down 6. And then for -1, sorry. -3, 7, you go to the left 3 and up 7. That point will be up here. And for -2, 6 will be to the left 2 and up 6. And then for -1, 5 will be to the left 1 and up 5. And then for 0, 4, we stay at 0, but go up 4. So that point is on the y-axis. And then 1, 3 will be to the right 1 and up 3. And then for 2, 2 will be to the right 2 and up 2. Finally, for 3, 1 to the right 3 and up 1. So as you can see, those points form a straight line. And if we connect those points, you will have the graph of the line y equal 4 minus x. Y is equal to 4 minus x. Okay. Now here's another example. This time we got the absolute value of x plus 1, and that should read y is equal to the absolute value of x plus 1. Y equals absolute value of x plus 1. And you're going to select integers for x starting with -4, ending with 2. Now, if you recall from other classes, the absolute value, that's the distance a number is from 0 on a number line. Also, you should know that absolute value will always be positive. It will never be negative. So, and we're starting from -4, then -3, -2, -1, 0, 1, and 2. Because you're told to select integers starting with -4 and ending with 2. And our y is equal to the absolute value of x plus 1. So for each x, we're going to add 1 to it, and then we take its absolute value. Okay, so for x equal -4, this will be the absolute value of -4 plus 1. And -4 plus 1 will be -3. And if you take the absolute value of -3, you're going to get 3. So one ordered pair would be -4, 3. Now for x equal -3, we have the absolute value of -3 plus 1. Then we do -3 plus 1, that's going to be -2. Absolute value of -2 is 2. So another ordered pair would be -3, 2. And then for x equal -2, this will be absolute value of -2 plus 1. So when we do -2 plus 1, we're going to get -1. Then take the absolute value of -1. That would be +1. So another ordered pair would be -2 and 1. And for x equal -1, we have the absolute value of -1 plus 1. Now we add -1 and 1 together, you'll get 0. Absolute value of 0 is 0. So the next ordered pair would be -1, 0. And then for x equals 0, substitute 0 in, you'll get absolute value of 0 plus 1. 0 plus 1 is 1. Absolute value of 1 is 1. So that ordered pair will be 0, 1. And then for x equal 1, we'll have the absolute value of 1 plus 1. 1 plus 1 will be 2, and the absolute value of 2 is going to be 2. So another ordered pair for that will be 1, 1, 2, not 1, 1. 1, 2. And then for x equals 2, we have the absolute value of 2 plus 1. 2 plus 1 is 3. Absolute value of 3 is 3. So the last ordered pair for that would be 2, 3. Now here we're going to plot these on the coordinate plane. So in this case here, -4, 3 will be to the left 4 and up 3. Draw that point. -3, 2 will be to the left 3 and up 2. -2, 1 will be to the left 2 and up 1. And -1, 0 will be to the left 1, and we're going to be on the x-axis. And then for 0, 1, we stay at 0 but go up 1. And then 1, 2 will be to the right 1 and up 2. And then lastly, 2, 3 will be to the right 2 and up 3. Okay. So these are my ordered pairs for y equal to the absolute value of x plus 1. And if I connect those points, notice that the graph looks like this. And it is a V-shaped graph. It is a V-shaped graph. And the absolute value function is always going to be a V-shaped graph. But this one is just a variation of y equal to the absolute value of x. Okay. All right, next we're going to talk about intercepts. And there are two types of intercepts, x-intercept and a y-intercept. An x-intercept is the x-coordinate of the point where the graph crosses the x-axis. So here's a graph that I have here. of a line. Notice that this line crosses the x-axis at this point. We call that the x-intercept. And usually it's going to have the ordered pair a 0. And the y-intercept is going to be the y-coordinate of the point where the graph crosses the y-axis. So this line crosses the y-axis at this point. We call that the y-intercept. And usually the ordered pair for that would be 0 and b. B is going to be the point where it crosses the y-axis. And for a0, a is the x-coordinate where this line crosses the x-axis. Okay. So let's say in these few examples that we have here, we want to identify the x and y intercepts. So in part A, here we've got a graph of a line and the 2 points are given. We want to know what the x-intercept is and what the y-intercept is. So we'll start with the x-intercept. Well, this line is crossing the x-axis at this point. Okay, now that x-coordinate there is -3. Okay, and of course, it's on the x-axis, so that means the ordered pair for my x-intercept would be -3, 0. That's usually how we write the x-intercept, as an ordered pair. And the y-intercept in this case that's the point where this graph crosses the y-axis. Here's crossing the y-axis at this point right here. And on the y-axis is at 5. And it's the ordered pair 0, 5. Because we stay at 0, but we go up 5. So the ordered pair for that y-intercept is 0, 5. All right, now let's look at another example. Let's look at part B. Here's a line, looks like this. And we want to identify the x and y intercepts. Let's start with the x-intercept. If you look at this line is not crossing the x-axis anywhere. Okay, so that means that there is no x-intercept. So we can just say none for that. There is no x-intercept. Now for the y-intercept. Well, this line does cross the y-axis at this point. And it's at 4. So the ordered pair for that y-intercept would be 0, 4. So 0, 4 is the y-intercept, and there is no x-intercept here. All right, and let's look at this one right here. And we want to identify the x-intercept and the y-intercept. Well, the x-intercept here is crossing the x-axis at 0, as you can see. So the ordered pair for that would be 0, 0. And the y-intercept. Here's the y-axis. It's crossing the y-axis at 0 as well. So that ordered pair would be 0, 0. So here you have a case where the x-intercept and the y-intercept are the same. Okay. All right, so that does complete this preliminary video on section 1.1 dealing with graphs and graphing utilities.